Hey guys, this is Gigi from Kauai Community College. This is example 1 of a lesson called Implicit Differentiation. Okay, so we are taking the derivative now, but implicitly. What does that mean exactly? All right, so suppose you have an equation x squared plus y squared equals 25. Now, as you remember, this is an equation of a circle center at 0, 0, right? Center at 0, 0 right here. And the radius is 5. So you go up 5 over 5, over this way 5, and over this way 5, and you have a circle. So that's an equation of a circle. Now the question is asking you to find the equation of a tangent line when x is 4. So 4 is somewhere right here. And as you can see, if you go up to the curve or down, you actually have 2 points of tangency. So there are 2 tangent lines that we are after. Okay, so that one right there and this one here. Now, the equation of a tangent line requires the slope, right? And the slope of the tangent line is the derivative. So we have to go and take the derivative of this function. Well, I can't even call this a function. It is not a function. So far, what you have learned is if you can write it as y equals, which I think you can, y squared is equal to 25 minus x squared. When you square root both sides, you will get plus or minus square root of 25 minus x squared. So you can see the positive 25 minus x squared and the negative 25 minus x squared. And that would be the top half and the bottom half, right? So when you're taking the derivative so far, okay, so this is old stuff. If you can get it to be y equals 2, then you can just say, okay, so my dy dx, let's deal with the positive one first, would be chain rule will apply here. So the square root, derivative of square root would be 1 over 2 square root of 25 minus x squared multiplied by inside derivative, which is negative 2x. So the first dy dx is equal to negative, and 2 divided by 2, negative x over square root of 25 minus x squared. And then the other one would be the negative times a negative, that would be positive, right? So the other one would be dy dx. The second one would be positive x over square root of 25 minus x squared. So, and then you can go and find the equation of the tangent line at x equal to 4. But now this is old stuff. What are we doing here now? What is implicit differentiation? Implicit means I was going to say not explicit. So this right here is explicit, meaning it's the equation is y equals 2, right? So what if we don't have y equals 2 and we use it as just x squared plus y squared is equal to 25. Well, you know what? So magic happens here, and this is why I'm using my magic pen. Okay, now, as you can see, if we could, and if we did solve for y equals, then y is a function in terms of x, right? Y is a function in terms of x. So keep that in mind. We would say y is a function in terms of x. So what does that mean? that means y squared can be treated as a composite function because y really is f of x, right? So y squared really is f of x squared. Okay, so y squared right here could be treated as f of x squared equals 25, right? If we were to solve for y. So what that means is when we take the derivative of y with respect to x, we would have to apply the chain rule, okay? Whereas if we were taking the derivative with respect to x, the derivative right here of x squared with respect to x, that's not a chain rule because x is your variable here. So that will just be 2x, okay? But if we were to take the derivative here with respect to x, then this right here will tell you that the chain rule will apply. So that would be, bring the exponent down. You will have 2 f of x, which is y, multiplied by the derivative of f, and the derivative of f is, the derivative of y really is dy dx, is equal to the derivative of 25 is 0. Okay, so that's a little implicit differentiation for you. In other words, if we were to treat y as a function in terms of x, then when we take the derivative with respect to x, and that is why it's important to write dy dx. Okay, that's why it's important to write dy dx, or the derivative with respect to x. When you take the derivative with respect to x, x is your input right here. So y is a function in terms of x. So you would take the derivative using implicit differentiation here, meaning take the 2 down. So then you'll have 2y, and then you will have to multiply by the inside derivative, which is dy dx. And that is what the chain rule said. Okay? So that right there is your implicit differentiation. So now, to solve for dy dx, we just have to isolate this part right here. Okay, so then we would have dy dx is equal to subtract 2x over divided by 2y. So you will have dy dx is equal to negative x over y. Now, that looks just like this right here on the left-hand side. That would be negative x over y. And y is square root of 25 over x squared, right? But we don't have to go and express that in terms of x only. So you can go ahead and take the derivative with just y in there. And when we do that, we would have to treat y as a function in terms of x. So we have to multiply by the inside derivative, which is dy dx. So you'll have 2y dy dx. Okay. Now we would now go ahead and find the derivative. Find the slope of the tangent line at that point, right? Now, why is this a good thing to do? Because it's a lot simpler than having to deal with all of this square root here, right? We don't have to deal with all that square root there. We don't have to go and solve for y, okay? So here we go. To find a derivative at the point dy dx at x is equal to 4. Well, when x is 4, y is y right here would be 4 squared is 16, minus 25 minus 16 is 9. So then y would be y would be plus or minus 3, right? So now we have to go and find a derivative when x is, I didn't like how that is written, so let's rewrite that. Let's say when x is equal to 4, y is equal to plus or minus 3. So you actually have 2 points, 4, 3, and 4, -3. These are the points, and as we can see on the graph, there's 2 points of tangency there. So first line number 1 is, we would say y equals mx plus b. M is -x over y. So for your first point, m would be -4 over 3. X is 4 and y is 3 plus b. So I would say b is equal to, we would add 3 is 9 over 3. We would add 16 over 3. So b would be 25 over 3. Okay, so then the first equation is y equals -4/3 x plus 25 over 3. That should be the equation of this line right here, the one that goes downhill. Okay, then the equation of the other line is y equals mx plus b. Y is -3. M is -4 over -3. That would be +4/3. X is 4 plus b. So you minus 16 over 3 over here. So you have 25 over 3 is equal to b. So then the second equation is y equals 4/3 x minus 25 over 3. And that is the one that goes uphill right here. So you have this red tangent line here and the black tangent line here. Okay, and so this right here is what we call implicit differentiation. And that is how we do that. We don't have to solve for y. We just go ahead treat y as a function in terms of x, so that the chain rule will apply. Okay, so that the chain rule will apply here. Okay, that is it.